Hello friends, in today's lecture we are going to focus on the features of PyTorch library. So let's get started. This useful framework is based on Python and Torch and is mainly used for applications using GPUs and CPUs. Now let's discuss its key features and capabilities in detail. First feature is PyTorch is an optimized deep learning tensor library, which means that it provides the ability to perform tensor computing, which is the fundamental base of deep learning. It uses tensor for every variable, similar to NumPy's ND array, but with GPU computation support. And with this support, it gives tensor computing with strong acceleration. It also provides built-in automatic differentiation, which is how deep learning networks actually learn from datasets. Second important feature is it has a computation graph support at runtime. PyTorch is referred to as a defined by run framework, which means that the computational graph structure of a neural network architecture is generated during runtime. PyTorch uses a dynamic graph approach to computation, allowing users to have access to every level of the computation. This helps developers understand their code better and see exactly what is happening at each step in the code. Since the computation graph is defined at runtime, this allows direct integration with Python's built-in debugging tools. Next one is PyTorch provides deep neural network. It provides deep neural network which is built on a tape-based auto-diff system. PyTorch was developed to provide high flexibility and speed during implementing and building the deep learning neural network. As you already know, it is a machine learning library for Python programming languages. So it's quite simple to install, run and understand. Next feature is PyTorch's code is completely Pythonic, means which is completely based on Python. That means its codes are written in Python rather than writing in Java or C++, which helps us to quickly build a neural network model successfully. PyTorch is used with most popular libraries and packages of Python such as Python and NumPy. So we can say that its code is completely Pythonic. Next is PyTorch is imperative. What is imperative programming? Which performs computations as it goes through each line of the written code. PyTorch is imperative, which means computations run immediately, thus user need not to write the full code to check whether it is working or not. It allows you to efficiently run a part of the code and inspect it in real time. This advantage of this feature is that your code and programming logic can be debugged on the fly. Next is PyTorch backend is written in C++. Provides APIs to access highly optimized libraries such as tensor libraries for efficient matrix operations and CUDA libraries to perform GPU operations and automatic differentiation for gradients calculations, etc. Next feature is it is production ready. With Torch scripts, PyTorch provides ease of use and flexibility in eager mode, while seamlessly transitions to graph mode for speed, optimization and functionality in C++ runtime environments. Next is distributed training. In distributed training, the workload to train a model is split up and shared among multiple mini processors called worker nodes. These worker nodes work in parallel to speed up model training. Optimize performance in both research and production by taking advantage of native support for asynchronous execution of collective operations and peer-to-peer communication that is accessible from Python and C++. Next feature is robust ecosystem. An active community of researchers and developers have built a rich ecosystem of tools and libraries for extending PyTorch and supporting development in areas from computer vision to reinforcement learning. Next is cloud support. PyTorch is well supported on major cloud platforms, providing frictionless development and easy scaling through pre-built images, large-scale training on GPUs, ability to run models in the production scale environment, and many more. Next is native ONNX support. Export models in the standard ONNX, which is known as Open Neural Network Exchange format, for direct access to ONNX compatible platforms, runtime, users, and more. Next is mobile, which is an experimental. PyTorch supports an end-to-end workflow from Python to development on iOS and Android. It extends the PyTorch API to cover common processing and integration tasks needed for incorporating ML in mobile applications. In short, we say that PyTorch is a Python-based scientific computing package that is similar to NumPy but with the added power of GPUs for graphic rendering. It is also a deep learning framework that provides maximum flexibility and speed during implementing and building deep neural network architectures. That's all we have with this lecture. I hope you have understood. Thank you.